This video will be in by 4 p.m., just letting you know, okay? It's like 3:25 right now. So, projectile motion, PMO1. So I'm going to do one problem throughout. I'm going to give you some examples of how to work a problem out like this, and then you'll try number 2 on your own. So a ball is thrown straight up with an initial velocity of 56 feet per second. The height, h, of the ball, t seconds, after it's thrown is given by the formula h of t equals 56t minus 16t squared. Okay, so there's a couple of questions here. I'm going to draw this out so you have a good idea of what we're looking for. Now, this is not in great standard form order. Let's reorganize it to h of t equals negative 16t squared plus 56t. Now, negative 16 represents an object's fall to Earth through gravity, right? You know this is 9.8 meters per second squared, but when we want to convert it to feet, we want to convert it to negative 16, okay? So the A term is always going to be a negative 16 in regards to a ball being thrown in air. Now, the B term, or the second term that has a variable next to it, that's always going to be your velocity. So 56 represents the velocity of that ball being thrown in air. Now, something that's missing here is the height. So this question's a little bit off because if I'm throwing a ball straight into the air, that means I'm kind of releasing it on the ground because there is nothing over here. And usually the C term represents height. So because there's nothing there, this question's a little bit off, but we'll just kind of play with it, okay? So what is the maximum height of the ball thrown? Okay, maximum height is represented of the vertex. Okay, so if I want what is the maximum height, I'm looking for what is the actual height in feet. We're going to use the formula negative b over 2a, comma, the function's value at negative b over 2a to solve this. Now, because I want what and not when, this is the what. It's the y value of the vertex. So negative b is negative 56. Divided by 2 times a, which is negative 32, and that's going to give you 1.75, and that represents the when. It takes 1.75 seconds to reach the max height, but because I want the what, I'm going to substitute 1.75 back into both t values and solve. Please remember that when you put this back in here, you have to square it before multiplying by 16. The answer is 49 feet. Okay, that's the maximum height of this ball that's thrown straight from the ground up, which is bizarre. Now, part B says, what is the height of the ball after 1 second? Remember that t represents time in seconds, so you're just going to simply put 1 where the t values are and solve. So negative 16 times 1 squared plus 56 times 1. So 1 squared is 1. 1 times negative 16 is negative 16. Plus 56, you're going to get 40. So after 1 second in flight, the ball is at 40 feet high. Last question here, after how many seconds will it return to the ground? Please know that the ground represents the x-axis, so I'm looking for an x-intercept. With this one, it's not too bad. You could probably factor a 2 out or a 4 out and then solve from there. The quick version here is, if I have an x-intercept at 0 here, it's symmetrical about the axis. So if 1.75 represents halfway through to its vertex, I'm just going to double that. So my answer for part C is 3.5 seconds. Okay, now let's go back a second so we can get the 4 very distinct parts of projectile motion. I'm just going to do a random one. This is not related to this problem in any way. So let's say I have a projectile and this represents its flight in air. There are 4 things you need to know. Number 1, what is its initial height? Initial height is represented by the y-intercept. So you'll need to know the y-intercept, and to solve for the y-intercept, you plug in 0 for x and solve for y. 2, what is the maximum height? And that's very clear, it's what. And the what is the y value of the vertex. The third question that you may get, and I like to give this question, so be very careful, is when does it make its height? Or when does it make its max height? Someone's speaking. I don't know if that's possible in here. When does it hit max height? So the when is the x value of the vertex. So it would be the negative b over 2a part, while this is the function's value at negative b over 2a. Okay. And then the fourth question is, when does it hit the ground? And the ground always, again, represents the x-axis, so I'm looking for x-intercepts or solutions or roots or whatever. So those are the four things that you're going to need to know when you solve a projectile motion problem. So the second question is, hey, you're good. Let's go ahead for the second question. You can pause me and see if you can get it. It's actually pretty simple. Just do number 2. Ball is thrown upward from the ground. Its height, blah, blah, blah. Negative 16t squared plus 64t plus 3, where t is the time in seconds. The ball has been in the air. Only question is, what is the maximum height the ball reaches? So it's the what, okay? What is the maximum height? So again, this one has a height of 3, so it's going to be off of the x-axis a little bit. What is the max height? I'm looking for that point right there, which is the vertex, but I'm looking for the y value of the vertex because I want to know what. Okay. So if you've paused me and gotten that correct, you should have gotten 67 feet.